Hi students, in our today's session we are going to learn about a simple trick to find the equivalent mass of an element of a compound. Here students, some more examples I am going to explain to you, and here is the important formula what you have. Equivalent mass of an element is equal to atomic mass of the element by valency of the element. Here students, about these two, if you know about these two, atomic mass of the element, that means how can we find out the atomic mass of the element and what is the valency of the element. If you find these two, it is very easy to find the equivalent mass of the element. Let's get into the class now. Equivalent mass of an element. For suppose if you take the example of CuO. Here students, what is the equivalent mass of this copper in CuO? That is the question. CuO means cupric oxide. This is also called as Cu2O. That means copper 2 oxide. Nothing but CuO, cupric oxide. Okay. We have to find out the equivalent mass of this copper element in this compound cupric oxide. For this we have to calculate, first of all, according to this atomic number copper 29 and its electronic configuration. Why? Because we need to find out the valency of the element and atomic mass also. First of all, atomic mass of this copper is 63.9. Approximately you should take this as 64, and copper 29 is its atomic number, and coming to electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. This is according to the molecular chart, but students, this is the exceptional electronic configuration, so we should take 4s1, 3d10 like this. And here is the valency shell 4s. Here is the s orbital. So copper has only one valency electron. So according to this formula, atomic mass of the element, that is only 63.9 by 2. Approximately we have the answer 31.8. So students, we have here CuO. In the CuO, the name of this compound is copper 2 oxide. Copper 2 oxide. That means here is the valency, we need to take it as 2. So we should take this electronic configuration 4s2 3d9. That's why I have taken here as the valency as 2, the valency of the copper. So the final one is 31.8. that is the equivalent mass of this copper in CuO. In the next example, equivalent mass of copper in Cu2O, that is cuprous oxide. Cuprous oxide also called as Cu1O, copper 1 oxide. Here is the atomic mass of this element, same we should take 63.9, and by here valency of the element, here students Cu2O, that means Cu with this oxygen, and here also one Cu. So here only copper is going to form only one bond with this oxygen. So the valency of this copper is 1 here. So the same 63.9 is the equivalent mass of this copper in the compound Cu2O. Here is the valency of this copper 1, and here is the valency of the copper is 2. Okay, I hope you understand. This is about the equivalent mass of this copper element. We shall discuss with some more examples here. In this next example, find the equivalent mass of carbon in CO2. Here is the central atom. You know that carbon, atomic number is 6, electronic configuration 1s2, 2s2, 2p2. So this is the K shell, this is second shell, nothing but L shell. So here is the second shell, is the valency shell, nothing but outermost shell. It is containing 4 electrons. So it has the valency also 4. So carbon valency is 4. Now the atomic mass of this element. Coming to this C, carbon, atomic mass is 12. Okay, and by 4, valency of the element is 4. Now we should get the answer as 3, that is the equivalent mass of this carbon in CO2. Right, we shall go for the next example. Find the equivalent mass of boron in BF3. Here is the boron central atom. So boron atomic number is 5. If you have to write the electronic configuration of boron, 1s2, 2s2, 2p1. So this is the second shell. L shell is the outermost shell here. Then students, what is the atomic mass of this element means boron? So approximately 11 you should take by the valency of this element. Here only 3 valency electrons, so obviously valency also 3. Now you should get the answer 3.6, that is the equivalent mass of this boron in the compound BF3. In the next example, what is the equivalent mass of phosphorus in PCl5, phosphorus pentachloride? Here is the central atom is phosphorus, the atomic number is 15. Then if you write the electronic configuration of this, 1s2, 2s2, 2p6, 3s2, 3p3. If you count these electrons, you should get number 15. And this is the first shell, second shell, third shell, KLM. Here is the M shell is the valency shell, nothing but outermost shell. So this outermost shell contains here the 5 electrons. Now students, if you get this number 5, you should subtract that 5 from 8. That is 3. So for suppose here is a rule for this to find the valency of the elements. For suppose the valency electrons are 4 or less than 4. 4 equal to 4. Less than 4 also the same number you should get just as its valency. For suppose if you get the valency electrons 3, the 3 is the valency. If you get 2, the 2 is the valency. If you get 1 valency electrons, then 1 is the valency. And students, if you get 4, here already we have done about this carbon, valency electrons are 4, that is 4 equals to 4. So this 4 is its valency. If it is more than, greater than 4, if the number is greater than 4, then you need to subtract 8 minus that number, then you should get the valency of that number. Here coming to the phosphorus, here are the valency electrons 5, so you should subtract that 5 from 8, then the number is 3, that is the valency of phosphorus. Right, now coming to this, according to this formula, equivalent mass of an element is equal to atomic mass of the element by valency of the element. Here is the atomic mass of phosphorus. Students, how much? Atomic number is 15, so 30.9 by, here is the valency 3, then 10.3 is the equivalent mass of this phosphorus in PCl5. We shall go for the next example. Find the equivalent mass of sulfur in SF6, sulfur hexafluoride. And here is the central atom sulfur, the atomic number is 16. And if you write the electronic configuration for this, 1s2, 2s2, 2p6, 3s2, 3p4. Here 10, 10 plus 2, 12, 12 plus 4, 16. Okay, this is the first shell, second shell, third shell, KLM. Here is the M shell, that is the third shell, is the valency shell, nothing but the outermost shell. Now students, the valency shell containing here 6 electrons, so those 6 electrons are the valency electrons. Okay, then this 6 is greater than 4. So what we have to do, we need to subtract this number from 8. So 8 minus 6, that is 2. Now you can say that 8 minus 6 is 2. This is the valency of sulfur. Now coming to this formula, atomic mass of the element by valency of the element. So atomic mass of this sulfur is 32 by valency is 2. So 16 is the equivalent mass of sulfur in SF6. Let us see the next example. Find the equivalent mass of nitrogen in NH3, ammonia. So here is the central atom, nitrogen, atomic number 7. Then if you write the electronic configuration, 1s2, 2s2, 2p3. Then this is the K shell, L shell. L shell is the second shell here. It is containing 5 electrons. So these 5 electrons are known as valency shell electrons. So valency electrons. 5 is greater than 4. So 8 minus 5. 8 minus 5, that is 3. 3 is the valency of nitrogen. According to this formula, equivalent mass of an element is equal to atomic mass of the element by valency of the element. Here is the atomic mass 14 by 3. According to that formula, 14 by 3, so 4.6 approximate value. So this is the equivalent mass of nitrogen in NH3. Find the equivalent mass of phosphorus in PCl3. Phosphorus trichloride. Here is the central atom is phosphorus, atomic number 5. Here already we have done about this phosphorus. Again, no need to do that. 1s2, 2s2, 2p6, 3s2, 3p3. Here 5 electrons are the valency electrons. This is the valency shell. So 5 electrons means 8 minus 5. That is only 3. The valency of this phosphorus is 3. According to this formula, atomic mass of the element by valency of the element. So atomic mass is 31 by 3. Here is the formula, valency of the element. Now we have 10.3, the approximate value, that is the equivalent mass of phosphorus in PCl3. Okay students, this is about our today's session, how we can find the equivalent mass of the element presented in a compound. Here C, carbon in CO2, boron in BF3, P, phosphorus in PCl5, sulfur in SF6, N in NH3, P in PCl3. This everything I have done here. Students, next one, this is the complete formula. This is the simple trick you have to remember. Okay students, if you understand this class, you can subscribe to this channel for my further updates. Thank you so much. What is your opinion and what is your doubt? If you have any doubt also, you can convey in the comment section. Okay, thank you so much. Thanks for watching. Have a nice day.